Okay, we're going to look at the third part of functions in grade 10 here. It's hyperbolas. Now, hyperbolas are pretty strange looking. They have two branches like this, Here is a basic kind of hyperbola. It's y equals 6 over x. Well, there's the equation, or the function is f of x equals 6 over x. Well, if we were to think of numbers that would make kind of nice answers for y, 1 would be a good answer because 6 divided by 1, if x is 1, well, then y would be 6. So if x is 1, y is 6, that's how we'd graph it. We'd go 1 along and we go 6 up, and there's a point. Well, if we were going to try another number that would make it work kind of nice, 2 would be good because 6 divided by 2 is 3. So 2 along and 3 up. Hey, this computer graphed this thing perfectly. Another number that would be nice is 2. 6 divided by 2 would equal 3. So if I go, or 3 rather, if 6 divided by 3 would equal 2. So 3 along, if x is 3, y would be 2. And the last one, 6 divided by 6, well, 6 divided by 6, if x is 6, then y would be 1. If we connect the points, it makes this curve that looks like this. And the curve's really important, the shape of it. It curves like this, and then it takes off towards the x-axis, gets closer and closer, almost forms a straight line, but never touches it. That's really important. That's the shape of it. There are things in nature that work this way. When a comet comes and gets bent by the gravity of a planet but doesn't go into orbit, it just gets bent by it. It goes off and it's almost a straight line, just like this. It's a hyperbolic event in the universe. And here, look, see, this line gets closer and closer to the y-axis here, where x equals 0 all the time, but it never touches it. Well, that's the shape. Hey, if it's got a branch down there, what if we put -1 here? Well, 6 divided by -1 would give me, if I have -1, 6 divided by -1 would be -6. So if x is -1, we get -6. And similarly, we have -3 and -2 would work. If we divide by -6, we get -1, and for y, we get the same branch, but look, it's going off towards the negative axes here, x and y axis. So you have two branches that look exactly the same, kind of mirror images of each other. Well, that's the basic shape when you have a positive number over x. And in grade 10, we just put it over x here. We do something else out here, but we just put it over x. Guess what happens when you make this a negative number? Well, the branches are almost the same shape, but they change. This is how they change. If I made a -6 over here, well, if I have x is -6, if I put in -6 in here, -6 divided by -6 would give me +1. And if I put in -2, I get +3. So I'm putting in negatives, but I'm getting positive numbers. It creates a branch over here in the left. Oh, these lines here in the last question and this question, they have a special name. They're called asymptotes. The x-axis is one asymptote, and the y-axis is the other asymptote. The y-axis, the equation of which is x equals 0, and the x-axis, the equation of which is y equals 0, they're called the asymptotes. Let's take a look at this branch down here. If we put 1 in, -6 divided by 1, well, if we put 1 in for x, we get -6 out for y. If we put 2 in, we get -3. If we put it 3, we get -2. And if we put 6 in, we get -1 out. Little error there on the screen. If we put 6 in, we get -1 out. But it forms that shape right there. Okay, that's the basic shape. Always, you've got your two branches here inside the asymptotes. These branches get closer and closer, but never touch. If it's negative, this is the basic shape. If it's positive, this is the basic shape. So two shapes for a hyperbola. And everything, all hyperbolas take this form. The ones that we're going to look at take this form. Okay. I hope that this helped. All right.